So we're going to look at some examples. In particular, we'll look at examples using what the conjugate looks like when the two quantities are both square roots. So here's square root of a plus square root of b times square root of a minus the square root of b. That product will be this thing squared, which will be a, minus that thing squared, which shall be b. So you just get a minus b. So we'll see that happen here. We have the 6 on top. We've got square root of 8x, so that's 8x is a, and 2x is b. Multiply by the conjugate. Like that. And then you just get this minus this. So in the denominator, I just have 6x. Upstairs, I have 6. Oh, wait a second. 8x is 2 times the square root of 2x. Oh, I'll put it there. So this 6 is canceled. That's interesting. And then I've got these things, I can combine them together to be 3 root 2x. 3 square root of 2x over x. That's 3 times the square root. Having a hard time. 3 times the square root like that over x. Let's double check everything, make sure it's okay. I didn't notice that 8x could really be written as 4 times 2x. That's 2 times square root of 2x. I could have simplified this and made it 1. Have a monomial denominator, but I just didn't do it. I used the conjugate anyway. And then this became 6x. I had a 6 on top, they cancel, that's nice. But then I had to simplify the 8x. Root 8x is 2 times the square root of 2x. So I've got 3 root 2x's there. There they are, divided by x. That looks all right. Go on the rampage down here. Root 2 plus root 3. Root 2 plus root 5. I'm going to multiply by the conjugate, which is root 2 minus root 5. This will take some effort, I think. So downstairs, I should get this minus that. So that squared minus that squared, which is 2 minus 5, which is minus 3. Upstairs, there's all kinds of multiplications we have to do. So here we go. I have to do that, I have to do that, I have to do that, I have to do that. So we'll do the FOIL method. The first 2 gives me a 2. The outside gives me a minus root 10. The inside gives me a root 6. And the last gives me a root 15. Ordinarily, we could stop there. But I don't like this minus sign, so I'll just make it a plus sign. Here we go. So multiply top and bottom by minus 1. Minus 2 plus root 10. Minus root 6. Minus root 15. I'm checking the answer, make sure I didn't screw up. Looks like it's all right. So another place where sometimes we have radicals and we have to simplify is things that come out of the quadratic formula. So there's the quadratic formula. Those are the solutions to the quadratic equation with leading coefficient 6, coefficient of x 4, and constant term minus 3 set equal to 0. So we'll plug all that stuff in. Minus 4 plus or minus the square root, b squared is 16, minus 4ac, oh my, minus 4ac is 12 times 72, I hope, and 2a is 12. So we get minus 4 plus or minus the square root of 88 over 12. And we have to check to see if that's in simplest form. So we have to actually simplify this radical and see if there's not any common factors. So here we go, minus 4 plus or minus. There's 4 times 22 in there. So I can write that as 2 times the square root of 22 over 12. So now I see a common factor of 2. 2 upstairs, 2 downstairs. The bottom is 2 times 6. The top is 2 times minus 2 plus or minus the square root of 22. So canceling that 2, I get minus 2 plus or minus square root of 22 over 6. Sometimes people write that like this. Minus 1/3 plus or minus root 22 over 6. I'm checking my work. Looks like everything's okay. So that's an example of radical simplification that comes out of the quadratic formula. And these are just some crazy examples that we made up. And that should be the end of this section on multiplying and dividing radical expressions. And we'll see you next time with more fun calculations and elaborations and maybe justifications and definitions and theorems, who knows. We'll see you later.